This was Giordano Bruno's argument.
Who was that?
I never remember.
We never talked about Bruno.
He had just read Copernicus' book. God-fearing man said, if the sun has planets, maybe these stars in the night sky are just like our sun. And if they are, maybe they have planets. And if they have planets, maybe they have life. Heretical.
Oh, they killed him.
They killed You know what his last words were?
Let me guess.
This is Star Talk. Neil deGrasse Tyson, your personal astrophysicist. Chuck, you're the grab bag man.
I'm the man with the bag. This is Yusef Kazwini, who says, greetings, Star Talkers. Yusef from Damascus, Syria here.
Damascus?
That's right.
Whoa.
That's right. Ancient city, Damascus. I found your podcast recently and I joined the club.
Oh.
Welcome aboard, my friend. Here's my question. You often mention photons travel at the speed of light at all times.
Yep.
Working as an optics engineer and dealing with TIRF microscopes, I wonder how evanescent waves during total internal reflection, TIR, is thought of from a particle physics perspective. Are the photons moving at the speed of light, but somehow without propagating? Or the photons don't exist at all? But then, what is interacting with the sample on my microscope? Thank you. I love your work. P.S. Chuck, you surely deserve an honorary PhD by now, my brother. Oh, look at that.
My brother.
My brother.
Optics is a huge field.
Yes.
That does very important work on a lot of frontiers.
Okay.
Optics is, what do you do with electromagnetic waves?
Mm-hmm.
Do you bend them? Do you reflect them? Do you trap them? Do you heat? What do you do with them?
Mm-hmm.
An entire branch of physics and engineering addresses those questions. So I don't know how specific the example is that he's giving and how that would lend itself to my explanation. Okay. So what I will otherwise say is the speed of light is not just a good idea.
It's not just a good idea. It's the law.
It's the law. Thank you. That's a dated reference to 55 miles an hour speed limit when we wimped out and said we're not going to go fast anymore.
Right.
So that doesn't mean light always travels at that speed.
Exactly.
It means it will never travel faster than that speed.
Right, because you can slow it down.
So let's see how you do that. Okay, it turns out you sort of can slow it down.
Right, I got you. So the medium itself can slow the travel.
Yes,
however. Medium.
Okay, but the way it slows it down is fascinating.
Interesting.
Okay.
Okay.
So I'm a beam of light.
Just going on about my business.
Going about my business.
Look at me traveling at the speed of light. Nothing can be faster.
Nothing can be faster. Then you hit the air or you hit a piece of glass or a piece of water. This is for visible light going through what we would say are transparent object.
Right.
Okay. If you're transparent, it means the light stays coherent as it goes through.
Okay.
So that the waveform maintains its structure. If it does not maintain its structure, light can still get through, but we would not call it transparent.
Right. Yes.
You know the word we have for that?
Translucent?
Translucent.
Yes.
And lucent means light in Latin.
Latin, yeah.
Loose is light. Loose. So the light comes up to the boundary. Some light will get reflected.
Yes.
And optics people know and understand that. Okay? That happened no matter, you can't do anything about that. You can try to minimize it by having what are called these coatings that will delete any attempt for the light to reflect back. Right?
Yeah.
And you know, it's fun the way they do that. You have a coating that's half the wavelength of the light that you're using. So then the light goes through, and by the time it wants to reflect back, the light that's coming in is out of phase with it.
Oh, so it creates a disruption.
And it flattens the light.
Look at that. I never knew that.
Isn't that brilliant?
God, people are smart.
Yeah, so a coated lens prevents the reflections off of surfaces.
Interesting.
Okay, and cameras, especially zoom lenses and other big industrial cameras,
Right.
they have many, many lenses in them.
Yes, they do.
You can't have light reflecting off of shiny surfaces at every time there's a surface.
Yeah.
Okay.
You just end up with a blob at the end.
Just a blob at the end, and all the
Right,
light was
all the-
scattered everywhere. You got nothing.
Right,
okay.
right.
And when I say it reflects, because light will reflect off of practically any surface, whether or not it's a mirror.
Yeah.
That's what I'm saying. Okay.
As
so
a matter
now,
of fact, in photography, they have something called a bounce board, and it's just a stark white. I forget the color of white.
so it diffuses
but
the light that it comes back to
Right,
you.
and that's all it
Otherwise,
does.
a flash can be very harsh.
Right, exactly. So you bounce it off of there, and you get the light without the harshness.
Without the harshness. So now you took care of that.
Mm-hmm.
Now the light enters the medium. Between molecules,
Okay,
light is moving at the speed of light.
gotcha.
But it hits the molecule. I got to deal with the molecule. I got to go in and come out.
Damn it.
Yeah.
Excuse me. Pardon me.
Pardon me. Excuse me.
Excuse me. I'm so sorry. It's
Bada
like-
bing. Now I'm speed of light again until I hit the next molecule.
Right. And it's, oh, God, here we go.
Here we go again. Right.
It's like walking down a New York City street behind tourists.
Right. Yes.
Yeah.
Tourists are just in the way.
They are in
in
the
ways
way.
that New Yorkers are not.
That's right.
And I figured I analyzed that.
Go ahead.
I figured out why.
Why?
May I say?
Please go ahead.
I'll try to relate it to light going through a medium.
Okay.
Okay. Here's why. New Yorkers anticipate each other's trajectories because we've done this with each other before.
It's a dance that we know. Yes.
It's a dance we know. Whereas a tourist, they might step left unannounced.
Right.
Nobody told you to step left.
Yeah.
Because I'm about to pass you on the left.
Yeah, who does that?
Who does that?
Who does that?
But a tourist who's just ambling
Right.
on
Looking
the
up.
looking up,
All right.
ambling.
All right.
And so you can't predict what their next move is, but for other New Yorkers, you can.
It's true.
Not only that, there are people who are, I've walked perpendicular to people, they're on the sidewalk and I'm crossing the street. You time it.
That's
So
right.
that you
know
perfectly,
exactly
you know
when.
exactly.
No, it's a dance.
It's a
You
dance.
got to live here to know the dance.
Whereas the tourists will stop.
Right.
Well, now they just messed up my timing.
Exactly.
Okay, they'll look, they'll say, excuse me, pardon me.
Right.
And you get people, I'm trying to get in the subway, okay? And a train just lets out. There are people, tourists will wait for everyone to clear from the stair. No, you don't do
dummy. You make your path.
You make
and
your
they
path.
know you're coming
They
down.
know you're coming down.
They will move aside
They will
as
move
they
aside.
come down and you're going up.
Correct.
Right.
Correct.
Exactly.
Just because it's a massive wheel don't mean
You just
that-
maybe missed my train. You know that, right? That's what you did. Waiting in line to get on the damn stairs. What the hell is wrong with you? I'm late for work.
Get down.
Gosh. And by the way, stand back from the doggone platform. Not that I'm worried about your concerned about your safety. I'm late for work. You fall on the damn tracks. Guess what? Now I'm late. Okay, anyway.
How to give New Yorkers a bad name.
No. Anyway, so the light in the medium is bumping into the molecules.
the molecules
But
of the
in
medium.
between,
It is
it's
moving at the
going
speed
back
of-
at the speed. It's traveling at the speed of light.
Correct. So the combination of getting through the molecule plus the speed of light between molecules on average slows down the propagation of light through the medium.
Look at that.
This is called the index of refraction.
Ooh.
It's a beautiful mathematical construct.
I love it.
The index
of
refraction. Yeah.
Ooh.
Yeah. So
Oh, I love it.
and I'll tell you how it works.
Go ahead.
The index of refraction, you can use that in a formula to tell you how much the light will bend coming in or out of that medium. That's how you make a lens at all. Okay. But the index of refraction, if you take the speed of light and divide by the index of refraction,
Go ahead.
that's the speed of light in that medium. Ain't that something?
That is really cool.
Okay, so let's do the math. The index of refraction of diamond is 2.4. What is 1 divided by 2.4? 1 is like the speed of light. Divide by 2.4, what's the number?
Point
It's point
four something.
Exactly. It's
Point
about,
four
about
something.
0.4.
Yeah.
So light in diamond is going 40% as fast as it goes in a
In a
vacuum.
vacuum. That's awesome.
Isn't it?
Oh, I love it so
Yeah,
much.
yeah. And so diamond is one of the hardest
Right.
natural substances known.
exactly.
It's hard for light to get through as
Yes,
well.
it is, yeah.
And even though it's transparent.
Right.
And before we get get all emotional about light trying to get through the medium. Visible light can't get through most mediums. Like a brick wall, right? The light just ain't going through it all.
Yeah, it's just like, damn it. That's light trying to get through a brick wall. Damn it. Oh.
If light were given a voice,
right?
Let's try the brick. No, no. Let's try the steel. No.
Damn it! Damn it!
But other wavelengths of light are transparent in these other substances, as you know. So your cell phone works in here because the walls are transparent to microwaves.
Right.
Microwaves come right on through.
No problem.
No problem.
They don't travel well through plaster, though.
What are you talking about?
Because my house, the walls are plaster. My house was built in 1898.
I think there might be something else in your walls.
Oh, you know what? You're right.
You might
it's
have
a metal lathe.
Metal
lathe.
grid.
Plus, so here's what it is. It's plaster, then it's wood, then it's lathe, then it's metal.
I bet there's a metal mesh.
It's a mesh.
To hold up the plaster.
To hold up the plaster.
So you're in a Faraday cave, my son.
Oh, my God.
Faraday cage.
That's what it is.
That's right. If you're surrounded by a metallic anything,
yeah.
Okay, then the electrons in the metal will conspire to prevent electromagnetic energy from entering.
That's why I can only hear the voices when I go outside.
Yeah, so that's why. Don't blame the plaster. Damn, plaster ain't nothing to do with this.
Oh. Wow, look at that. Okay.
Yeah, back then they would put up the mesh.
Yeah, you put the mesh. And they put the plaster
it would hold the plaster up because all of the little, the grid of the metal.
Yeah.
So if you have multiple internal reflections, that's the light just going back and forth. Oh, by the way, check this out. Check this out. Okay, ready?
What?
Okay. So if I have two media with different indices of refraction. Okay. So I have light coming up from one. It crosses the border and it bends. Anytime you go between two media, the path of light bends. It will bend. Okay?
Right.
That's why sunset happened 5 minutes ago.
Right.
Because the light bent going from the vacuum of space to our atmosphere, and it gave us an extra 5 minutes of sunlight because it refracted around your horizon.
Nice.
Okay. So it will bend.
Okay.
Now watch this. It comes up and it bends.
Right. Yes.
Suppose I take the angle of the light and make it steeper, like this. Then that will keep this come further and further down. There's an angle at which the light never enters the next medium.
Oh.
Because this bend now takes it backwards into the medium itself. And it's called total internal reflection.
Oh, wow. That's something I avoid at all costs. That's why I can't sleep at night.
So that's that angle. It's still in the other medium.
Right.
Bam. Now it's total internal reflection.
That's pretty cool, man.
It's very cool.
I love that.
And you can know exactly what that angle is,
right?
How to do that. And so if you have an optical system where the light is just bouncing back and forth, it is within the parameters or you can have just a reflective surface as well.
Right.
Just a mirror would do that. Right. But anyhow, what you do inside your medium is your business. And what that then does to a beam of light. But yeah.
Interesting.
There it is. That's all I can do to illuminate. See what I did there? To illuminate that question. There may be other places to go in the physics of optics that I would not have known to touch.
Very cool, man. What a great question, and thanks, Youssef, and welcome to the club. Today's episode is sponsored by Delete Me, a service I use to take back control of my personal online data. You know, I've been on the internet a long time, and for years, I thought the worst thing that could happen to me was reading the comments section. Well, I was wrong. With the advent of AI, data breaches, and data brokers, your digital footprint isn't just a history, it's a target. You know the old saying, if you're not paying for the product, you are the product? That means that every free service you've used for the past decade or more has been collecting your personal information. Now, usually, they just feed you ads, but often they turn around and sell your information to data brokers. In the past, that just meant getting billion robocalls every single day. But today, that data is fuel for AI and scammers, and it's floating around for anyone to buy legally. That's crazy, right? This is where Delete Me comes in, my new favorite tool that gives me the reassurance that my personal information is protected and removed from hundreds of data broker sites, reducing the risk of my data getting into the wrong hands. So how does it work? Simple. You sign up for Delete Me, and they become your personal privacy army, scouring the internet for major data brokers selling your personal info and submitting opt-out requests on your behalf. Basically, you're paying Delete Me to get rid of the downsides of the entire free internet. I want my information protected, and this is the most straightforward way to do it. It's simple, streamlined, and always on, giving me the peace of mind I need after all these years on the web. So if you're like me and you aren't so sure about how much your personal data is being sold on the web, you should sign up for Delete Me today. Head to joindeleteme.com/StarTalk and use code StarTalk for 20% off all consumer plans. That's joindeleteme.com/StarTalk. And we never had this conversation. You know what I'm saying. All right, this is Big G. He says, hey there, Lord Nice, Dr. Tyson, Big G here from California with a question for each of you. Are there any cosmic mysteries that you are most looking forward to knowing their resolutions, but sadly may not be resolved in our lifetimes? Bonus points if you can name mysteries that we are so close to resolving, but it's probably just beyond our reach.
Okay, you go first.
Well, see, mine is the easiest because I just want to know what exactly is causing the acceleration, the expansion of the universe.
Like everybody else wants to know
because that's everybody else. But the reason is because I believe that it's a pressure from outside of our universe that bleeds through. That's what I think it is. And I just...
You think there's a puppet master?
No, well... I'm not going to call it a puppet master. I think there's a bleeding. That's what I'll call it.
An injured puppet master.
An injured puppet master.
Leakage of pressure.
Because if we were to find that out, now we have to explore the leak. And that means we're looking at a whole nother universe. And to me, that's fascinating.
That's interesting.
Yeah.
You have to then explore
the leak. You got to explore the leak now.
Okay. So I can't top that. That's good. No, I would say I don't think we're going to know for sure if there's life in the universe in my lifetime.
Whoa.
Intelligent life in the universe.
Well, then you win the bonus points because that is something we are very, very close to, but it's very possible we may not find in our lifetime.
Yeah, I don't think in my lifetime we will know that. What we will know in our lifetime is if there's any life at all
outside.
In our own solar system.
In our own solar system.
Okay, because we're looking at Europa.
Right.
We did a whole episode. We went to JPL,
right?
Jet Propulsion Labs.
That's right.
NASA in Pasadena.
That's right.
Talked to the Europa Clipper people.
That's right.
Talking about what are they going to do, how are they going to measure it, what's beneath the ice. So we will know whether or not there has ever been or is currently life in our solar system other than on Earth.
Yes.
I think that will happen. But it would be sad if there is no life other than life on Earth. You know what has been said? Mm-hmm. How profound it would be if we discovered intelligent life in the universe, but how more profound it would be if we discovered that we're alone.
Listen, the second one is far scarier.
It's a little scarier,
than the
isn't
first, because that means
you kind of want neighbors, don't you?
All of this was a mistake.
No, it would feed many religious thinking that the whole universe is just for us.
That's okay.
What kind of face was that? Some branches of Christianity and perhaps other religions as well require that life on Earth be the sole object of God's creation.
Okay, I'm just going to say it, and please don't judge me here. I'm being logical, and I'm thinking like God. All right? That's the dumbest crap I ever heard, and here's why it's stupid. I don't need to do all this, okay? I don't need to do...
You're God. You're God speaking.
I'm God right now. I don't need to do all this to show you that you're the only thing necessary and good and my central and crowning creation. As a matter of fact, all I really need is the sun and the earth, because that's the energy system that makes all of this happen.
Yeah, nothing else matters.
Nothing else matters. So if the sun, like a hydrogen atom, had just the earth going around it, then I would say there is a God and he made this just for us. But when you look at the vastness of the universe and the trillions of galaxies, all of which containing stars, billions and billions of stars in each galaxy, to a place where we can't even fathom the number of celestial bodies that are out there, then what you're saying to me is I'm stupid and I like to waste my time. I like to waste my time. That's what I'm doing.
So God is an inefficient manufacturer
and that's it.
of worlds.
Right. It doesn't make any sense. So either there's a lot more of us out there, not meaning us, but life, all over the place.
This was Giordano Bruno's argument.
Who is that?
You don't know Giordano Bruno? I never remember.
We never talked about Bruno.
Bruno.
Who's Bruno?
He's a monk.
I'm sorry. That just sounds funny. But go ahead.
A 16th century monk.
No, really?
In Italy.
Yeah.
Yeah. He had just read Copernicus' book, De Revolutionibus, which puts the sun back in the. I say back because the Greeks knew this, but it got lost in the Dark Ages. But the sun back in the middle of the known universe.
Okay.
He, religious man,
okay,
God-fearing man, said, if the sun is in the middle and not Earth, that means Earth is a planet going around the sun like Jupiter and Mercury and Mars and Venus. If the sun has planets and we're life on a planet, maybe these stars in the night sky are just like our
us.
sun. And if they are, maybe they have planets.
Wow.
And if they have planets, maybe they have life.
Right.
Heretical.
Oh, they killed him.
Because that meant Earth was not the object of God's creation.
There you go.
So they put him on trial, sentenced him to death.
Oh my God.
Burned him upside down, naked, in the Campo di Fioro, the piazza in Rome.
Right.
And I think that's in Rome, not Florence. And they drove a stake into his mouth
to shut his ass up,
so that even in the afterlife he would not preach such heresies.
We don't.
Okay.
We do not deserve to be a species running things.
Okay. You know what one of his last words were?
Let me guess.
Okay, before that.
Okay. What was his last word?
He says, he had a few good last words. My favorite among them was, your God is too small.
Yes. Ooh. Way to go out.
Way to go out.
Way to go out, man. Your God is too small.
Oh, too small. Your God of just earth and the sun?
Yes.
Yeah. So anyhow.
Oh my God. Okay. First of all, I'm got to read up on this guy. Bruno is his name, huh?
Giordano Bruno. Cool name too.
So check this out. Some people know my background, but one of my last words before I left my other life, my religious life, was over this whole idea of homosexuality. I never understood it. I still don't understand it, like why people have a problem with it and why would God have a problem with it. I couldn't get around it as I'm studying to become, a minister.
But I thought it's because it's in Leviticus.
Yeah, but Leviticus is full of shit. Anyway, I mean, honestly, you know how many people have read Leviticus? Me being one. Okay. So anyway, one of my last.
You know what someone told me? A Jewish person told me. Leviticus are just suggestions.
Kind of.
Because if they were important enough, they would have been a commandment.
It would have been commandments. Right. No, seriously. Yeah. The Levitical law. And by the way, it's a Levitical law for the priests. Okay. Anyway, I said, a God that needs me to fight this battle for him is not a God I want to serve.
Ooh.
If God needs me to fight this battle,
Homosexuality.
yeah, right.
What?
If that's the battle that I got to fight,
Interesting.
I got to be worried about two dudes doing it. Like, that's what my God is all about.
consenting dudes.
Two consenting dudes doing it. Like, that's what I got to worry about. I can't serve that. I got to be out. Anyway,
Interesting.
so I love this Bruno dude, and I'm going to
Check him out.
I'm going to check him out.
All right.
Awesome.
Oh, by the way, there's a memorial to him in the square.
I'm sorry.
Looking very
A little late. Sorry.
He's there. He's got his monk robe on, and he's very solemn there.
Giordano Bruno.
Yeah.
Oh, I can't wait.
I think it was 1601, something like that. Yeah.
That's amazing. Wow, what a great story. I love it. Okay, this is Keith Koenigsberg. Koenigsberg. Yes.
With a
Keith,
K.
With a K.
Yeah.
Keith says, hello, Team startalk. This is Keith here, writing from New York, big city of dreams. Here's a question I've been
It's
wrestling.
like the first one we've gotten from New York, New York.
It's so true. We don't get a lot of New York people.
We're right here in my office in the Hayden Planetarium, and we're getting from Syria, from
Pakistan, from all kinds of Chile.
All right, that's cool.
No. He says this, LIGO has used light waves to detect the shrinking and expanding of space caused by passing gravitational waves. But wouldn't the waves be in and out of the material of space? If space expands, don't your light waves stretch along with it? And any other measuring rod, as Einstein would say, and cancel out the change. So
Yes.
Okay. Explain to me
What the hell he was
what the
just
hell
asking?
he's really asking. Because I'm confused.
What he's saying is we have a laser that bounces back and forth.
Right.
Okay? We measure the trip of that laser with very high precision.
Very high precision.
What he's asking is if a gravitational wave washes over the measuring device, how's the measuring device going to know if everything about it moves with it?
I got you.
Okay. So if I'm measuring your height, how tall are you?
I'm 5'10".
You lying, Mo?
No, I'm 5'10".
Okay, I'll give you five. I'm gonna give you 5'9". That's it. Okay. So you're 5'9", and I have a 5'9" tape measure, and you look at it, it says 5'9", right? Okay. Then we stretch both you and the tape measure. You're still 5'9".
True.
Unless you have some other way to measure what just happened.
They're called Ron DeSantis heels. Anyway, sorry. Go ahead.
Okay. That's like a news item from like 8 years ago.
It's last year, but who cares?
Feels like 8 years.
Yeah, it does, doesn't it?
So you're absolutely right. If I stretch you and the tape measure, you're still 5'9".
Right. But we're talking about something washing over the measurement
That's
system.
fine. So now watch. It's because of that fact that LIGO, Laser Interferometer Gravitational Wave Observatory, has two lasers at right angles to each other.
Oh.
So if one of them stretched, moving that way, it's not stretching the other one.
Way.
And it's those two path lengths that we compare with each other.
Gotcha.
That's how we know. If a gravitational wave washed over us. So we got smart people designing this.
That, first of all, is a brilliant question. And secondly, those people, they deserve the money.
What money?
Whatever money we gave them to make LIGO.
The funding.
Yeah.
Yeah.
Whatever the funding was, they
National
deserved
Science
it.
Foundation.
Yeah, they deserve that. Because that, first of all, what a simple little answer to what could be, altered results.
Right.
Interesting. I love it.
So 1915,
Right.
Albert Einstein puts forth the general theory of relativity.
Okay.
A year later, he uses the general theory of relativity to predict the existence of gravitational waves.
Right.
But he doesn't think we'll ever detect them.
Of course.
Because the energy level's so low. And how
would you detect
It's just 1916, for goodness sake. Okay. That same year, he publishes a paper on the stimulated emission of radiation, which is the foundation for the laser.
Right.
100 years later, in 2016, or was it 2015? 99 or 100 years later,
Right.
we discover gravitational waves using lasers.
Damn. Bro, Einstein was gangster.
Gangster.
He was gangster.
Gangster.
Okay?
Gangster.
That's like a chicken laying an egg so you can discover an egg.
Okay. You made it way less profound than it started out. Normally, you would digest it into something more profound.
I know, and poetic.
But that was worse in all counts.
It probably is, yeah. Go ahead. That's Einstein. He was gangster.
Gangster.
Oh, yo, that's dope.
All right.
Okay, that's really, God, if you, see, this is, if you don't love science.
Don't get angry with people.
If this does not make you love science, I swear.
I'm gonna go kick your ass.
You should, you know what? You should get a dumbass poker. Bang, right up. That's what a big poker that's brands. Anyway, God help me. So good. That is so good. Unbelievable. Okay. Scott Jarbo says this. Hello, Dynamic Duo. My name is Scott Jarbo from Seattle, Washington. And you mentioned, I believe recently, that we cannot gather data from sending a probe into a black hole, as we would have no way to transmit any data collected because it could not escape the gravity of the black hole. Okay. So my question is, understanding we can't at this time, if we quantum entangled the instrumentation of the probe with a twin probe that was kept external, could we not record that data that way? And in fact, in general, would that not be a feasible mechanism for interstellar communication in faster than light speed? The state of each should instantaneously mirror. Is that correct? Quantum entangled.
I'm not a black hole entangled expert.
Okay.
So it feels plausible that you should be able to entangle particles even though you lose one of them into the black hole.
Right.
It feels like you should be able to do that. They should
know what the other particle is doing, even though it's inside of a black hole.
Should. But, and so someone interacts with the particle that just went into the black hole, which then triggers the measurement of the one outside the black
particle
hole.
Outside of the black hole.
And that way you knew something happened in the black hole.
Right.
I don't see why that wouldn't be possible. I don't know what to say.
I don't know what to say. If you don't know what to say.
I don't see why not.
Okay.
No. But they want to talk about faster than light communication. Right. The problem is your thing has the information already built into it.
Right.
You can't, after the fact, change that information.
Now that we know.
So this normally communication happens where, turn left instead of right.
Right.
All right. And if it's already built in, I can't do that.
Right.
And so there's still some jury that's out on how we will fully exploit quantum entanglement as a communication mechanism going forward. And from what I have read, it's less favorable than you want to believe it is.
Okay.
For these reasons.
All right.
Okay.
Right.
All right.
This is James Peterson. Hello to my personal astrophysicist and personal science comedian. My name is James Peterson from Lacey, Washington. Here are my scenarios and related questions. 2 manned spacecraft are approaching each other at a constant rate within a huge cosmic void. Neither one is accelerating or decelerating. There are no other visible or detectable objects within this cosmic void, just the blackness of the vacuum of space. Neither of them knows if they are moving or stationary. They only know that they are approaching each other at roughly 20% the speed of light. What would be the reference point for each of them to determine their individual velocities, assuming that they could compare rates of time on their clocks as they pass? Could the relative speed of their clocks be used to determine their individual velocities, and individual velocities relative to what? Everything is relative, you know?
Do all these people have jobs? To have the time to come up with questions like this?
I know. It's just like, this guy, weren't you satisfied with 2 trains leave the station at the same time, one in Chicago, one in D.C.?
He didn't stop there.
He didn't stop there.
So what he's not getting right in the question, the simple point, is each of them does not know if they're moving. as far as they're concerned, they're stationary.
Right.
So he's saying, well, they approach each other. I don't know that. As far as I'm concerned, I am still in a void, and I see this other craft coming towards me.
Right.
There it is. That's the only thing that matters. That's it.
Right.
That's it. And so I will measure how fast he's moving.
Right.
There'll be time dilation relative to me as a function of how fast it's going. It's not more complicated than that.
That's it.
We don't have to do a double calculation.
Nothing.
Or anything. And we will each measure exactly the same thing about each other.
Right. Because it's relative to the observer.
It's relative to the observer.
And
correct.
so each one of us will see the other ship coming. We will measure that.
And we will think we are not moving
and
at
we're
all.
going to still stay stationary as far as we're concerned.
Correct.
And when the ship goes by, it's like, whoa, did you see that?
Right.
And that's going to be the end of it.
That's the beginning and end of it.
Right.
And there were jokes back in 1905 when Einstein came out with this for the first time, special relativity. They try to egg him on. Say, hey, Einstein, when does Grand Central Station arrive at the next train?
That's actually kind of fun. Damn.
So,
boy, haters no matter.
I know.
There's
I
haters
know.
no matter what.
I know.
Even Einstein had haters. Look at that. All right. So this is Vexonar who says, greetings, Dr. Tyson.
What is who?
Vexonar.
Vexonar, okay.
Vexonar, who says, greetings, Dr. Tyson and Lord Nice. What are you putting in your time capsule for the next generation to open?
Oh, so.
Interesting.
So.
Yeah.
So.
Go ahead.
I just got to say this, okay? And there's a book written on this. I forgot the name of it. Forgive me. I don't remember the author. But there's nothing less interesting to a subsequent generation than an earlier generation's time capsule.
Wow.
And the evidence of this is nobody remembers where any of the time capsules are buried. There's ceremony, there's the mayor speaks, and then as things move on and culture advances and technology advances, no one cares what your sorry ass from 40 years ago thought was modern.
Right.
And
exactly. Oh, look at this, a phonograph.
I was in Flushing Meadow, near the Unisphere.
Okay.
Tell everybody what the Unisphere is.
It's the thing outside of the old World's Fair Stadium. It's a big giant globe, right?
Yeah. I mean, it's the one that it's what anyone thinks of when they think of the Flushing Park.
Yeah.
Okay. It's Earth. U.S. Steel created this for the World Fair.
The World Fair.
And there's these three rings around it,
Right.
Evocative of John Glenn's 3 orbits around the Earth.
I did not know that.
I'm just saying. So there I am. This is maybe 15 years ago. I'm just sitting on a bench. I forgot why I was there. I don't remember. Forgive me. I don't remember why I was sitting on a bench in Flushing Meadow. Because I don't live in Queens. I usually am just driving through Queens.
Okay.
But I'm sitting there, and I look down, and under the brush, I parted for. Here is a time capsule from 1965. It was like a time capsule buried in that spot. No one cared.
And they just put a bench on it.
No one cared.
Nobody gave a damn.
There's no memorial around it, no ceremony, nothing.
Exactly.
We have a time capsule for the Rose Center here. And they asked me, what do I want to put in the time capsule? So I thought about it. I said, okay, I'll tell you what I put in it. I put a Metro card in it.
Oh, and guess what? That's a good thing to put in it because they don't exist anymore. So you were ahead of your time.
So I put in a Metro card. I think I put in an iPod.
Oh, okay.
Okay.
And interesting.
This was modern stuff.
Right.
At the time. We're all excited about it. But who cares?
Right. Because like both of those things are non-existent now.
They're non-existent and no one wants
and
one.
Nobody wants one.
No one cares about them. No one wants one. We moved on.
Right.
So for me, time capsules, though they mean well, I think are one of the greatest misplaced investment of our attempt to communicate with the future.
Okay. That's very cool.
I don't want to be victim of that.
I don't, right.
So no, I'm putting
nothing in it. I'm putting the transcript of every speech given by President Trump. Just the transcript. No audio and just the transcript.
Just the words.
Just the words.
Okay.
So that they could read it and go, what the? How?
Words
What?
of the most powerful person in the world.
Exactly. The most powerful man in the world said these words. Okay. Let's see it. Thomas says this. Dr. Tyson, Lord Nice, greetings from Hungary.
Hungary, love it.
Yeah, way to go. In an earlier episode, Dr. Tyson said that mathematically, the horizon of the universe has all the same properties as the event horizon of a black hole. That got me thinking, if our universe would be a black hole, knowing that gravity has no limits on range, could the continuous falling in of matter into our black hole universe explain accelerating expansion of our universe? And if that would be the case, is there any possible way to detect such matter since it would be at the edge of our known universe? Thank you for your work.
That would be true. Good question. That would be true if we were not expanding exponentially.
Right.
Okay, so the fabric of the universe is expanding, and because of that, there's nothing falling in.
Right.
It's taking it with it
exactly.
out to the edges.
Yes.
So,
Yeah,
but if we were not that way, and we just had our horizon, an object moving could just kind of cross our horizon and show up. And it'll just show up, okay, if it moves in that way. Or you wait enough time, I should say that differently, wait enough time, that horizon washes over the next set of galaxies that are sitting there waiting to be seen by you. Because right now the horizon is 14 billion light years away. Wait a billion years. Then it's 15 billion. That's a whole extra universe that's in your horizon.
Right.
You know the scariest day of them all will be?
What?
You wait another billion years and there's no new galaxies to reveal themselves. It meant you reach the actual edge of the universe.
Yes. Not just the observable universe, but the edge
of the whole universe itself.
Right.
That's a scary day right there.
That's kind of a cool day, though.
It's kind of cool.
Yeah.
But it also means cosmology will evaporate because at that distance, we're seeing things that are that old getting born. But if there's nothing there, then the galaxies that a billion years ago were just born, they're now a billion years old.
Right.
In another billion years, they're 2 billion years old. And there's nobody new coming in that's just being born. Gone is cosmology.
Look at that.
Yeah.
Wow. That is a scary day.
I have it on my calendar.
All right. This is Bill.
This might be the last question, I think.
Okay, last question. Look, Bill gets the last question. Bill says, "Hi, Dr. Tyson, Lord Nice. This is Bill. I made it easy for Chuck to say, shut up, Bill."
This is how you pronounce Bill.
He says from Bannock, Scotland. And he says, "I need some cheering up considering the state of the earth in a few hundred years, maybe sooner, if he whose name we shall not mention gets his way. From now, when humankind has finally turned Mother Earth against us, which species that exists just now would you imagine will pick up the cloak of dominance that we humans held for a few thousand years? Will they be land-based, sky or sea-based, or even amphibious? What is it about the species that leads you to that conclusion? Or do you see a bright future for us and what that future would look like in the event we are still here in 25? Ooh. A question that is, I'll say, laced with hope, but yet very dark, very dark and daunting.
Yes. It's both hopeful and darkful.
Yes.
So I have some important replies to that.
Go ahead.
So first, there's a book written, forgive me, I don't remember the author. It's called After Man.
After Man.
Something like that.
Okay.
Okay?
And is that like...
What it does is it renders humans extinct and it looks at other animals to see what would become of them.
Oh, I thought it was a woman who left her husband for a lesbian relationship. After Man. I am so much happier, I can't tell you how much better it is
with no man.
Which, by the way, seems to be the consensus, by the way.
Apparently.
Yeah.
Right.
Anyway.
So
After Man.
And so I looked it over. I didn't read every word, but it's highly illustrated. It's intriguing.
It is.
Okay.
To think about.
Okay. Now,
Because who would have bet on us?
Consider, what's the largest animal there ever was?
From what I understand, it is the blue whale.
And it is alive today.
It's alive today.
And what kind of animal is it?
It is a mammal.
Mammal.
Yes.
Okay. Do you know the size of the smallest mammal?
I don't, but I think it's pretty small.
It can fit inside of it like a teacup.
Yeah.
It's like this big.
Yeah.
I think it's a marsupial.
Yeah, it's like a little shrew or
Marsupials
something
are mammals,
like
I think.
that. Marsupials are mammals.
Yeah. It's some little thing.
Yeah.
Okay. This big and the whale. So mammals have the capacity to not only occupy practically any size range, but practically any place on Earth. They can figure out how to live there.
And we are on every place on Earth.
Basically.
We're even
So are bacteria, but in terms of animals.
yeah, we're a different kind of bacteria. We're more like a virus. No, I'm talking human beings.
So unlike reptiles and other cold-blooded creatures, they can't exist in cold climates. Right? Because they would just freeze and die. But we maintain our body temperature no matter where we are. All right. The reason why I'm saying this is this book said, if that's the case, what's limiting the size of rats?
I don't know.
I'm going to tell you. You ready?
Go ahead.
I could be wrong, but just put it out there.
Cats?
The size of, not New York rats.
Yeah.
Okay. The size of the hole they will run into so that you don't harm them.
Really?
Okay. Just think about that.
Yeah.
Go look in the subway. You see rats?
Yeah.
They'll crawl, and there's a hole they go into.
There always is.
There always is.
No matter what rat you're talking about.
There always is.
Right.
There's a hole.
Yeah.
Okay. If humans aren't here, they don't need the hole.
Oof. Which is why you get some, they're not rats, but they are part of rodentia in certain parts of the world where they're as big as like
a capybara.
small horse. Like a capybara.
The biggest rodent is right. Small horse. So, rodents, which are one of the most successful branches in the tree of life.
Yeah.
For how many they are and how many species there are. Okay. How many species are there in the branch called Homo?
I don't know. Not one. It's Homo sapiens.
Homo sapiens.
We're the only ones left.
Correct.
Because when you say how many species, I was trying to think
we're
of
the only ones left.
Denisovians.
That makes us
Homo erectus
quite fragile on the tree of life.
Yeah.
Rodents.
So many of them.
Okay, so this book foresees that basically rodents take over. And they become huge. Like people-sized.
Oh.
Like rats that are people-sized.
That's scary.
And there's nothing to...
And nothing to stop them.
Nothing to stop them. Nothing to stop them.
You dirty rat.
And it talks about the aquatic creatures.
Right.
What is it? The penguin gets really large or something.
Right.
So when you take away a predator, there's no longer a limit on the size of what it is.
Okay.
So Earth after humans, I picture a natural history museum.
With a bunch of giant rats walking through.
Looking
at us.
I know. And it's, Mommy, Daddy, what's that? And there's like human skeletons there. Say,
those were called dumbasses. They used to run the earth at one point, sweetie. And then
I was talking about the dinosaurs. They ruled the earth.
Yeah. So these dumbasses, what they like to do was burn stuff. Dig it out of the ground and burn it, sweetie. And they would burn it and it would release something called carbon into the atmosphere. And then they all died and now we run
And then they kill each other for any reason at all.
And they also like to kill each other. You know?
So that's the future of Earth. Because Earth and other life forms are going to survive us.
Right.
For sure.
Right. Exactly.
Okay? All right. So don't do this all stuff about this green movement. Save Earth? No.
Earth's going to be fine. Save your ass. That's what you need to do. Earth's going to be fine. Save your ass.
Your ass. That makes a lesser poster in a march.
Exactly.
Save your ass.
Save your ass. Okay. All right.
But in terms of hope?
In terms of hope.
Here's the hope. Our boy here is from Scotland.
That's right.
I gave a public talk a few nights ago. Someone asked me what was my favorite song ever.
Really?
And you know what I told them?
What?
Amazing Grace.
Okay.
I think that's the song of the millennium. Amazing Grace.
It's a beautiful song.
It's a beautiful song. And you know how it's most beautifulest?
Okay. No.
In bagpipes.
Okay. I'm not a fan of bagpipes.
you would be if you heard it and play Amazing Grace.
You know,
That's all I'm saying.
okay.
And bagpipes, that's a Scottish thing.
It really is.
So what I'm saying is, when life and the world gets us down, we should hear chorus of bagpipes performing Amazing Grace. How sweet the sound.
Let's save
the wretch like me. Because we're all wretches and we need saving.
It's true. From each other.
So Scotland may be the savior of us all.
Well, look at that.
All right, we gotta go.
We gotta go, right?
Oh, man.
That was
All right.
fun. That was so much fun.
All right, this has been yet another Cosmic Queries. What kind of edition?
This is Cosmic Queries Grab Bag.
Grab Bag with Chuck Nice, of course. Neil deGrasse Tyson here, your personal astrophysicist. Always good to have you, Chuck.
Always a pleasure.
As always, keep looking up.